Okay, we were very recently involved in an occupational noise study at an industrial facility where there were a number of forklifts in use. In most cases, we carry out attended noise measurements where we stand adjacent to one of the operators and measure the noise contribution at each ear and quantify the exposure of that employee. This particular situation, however, arose where we were unable to remain at the employee's ear because it related to forklift drivers. So what we did was we set up a microphone in close proximity to the forklift driver's ear and left the forklift driver for a period of, let's see, we're talking about from say 14:20 in an afternoon till about 15:10 or so. So that's 52, about 52 minutes. So essentially we let the operator go about their business, carrying out the various activities and so on, and we measure the noise climate. So just to show you the noise climate you're looking at on screen at the moment, this is the LAEQ, which we captured on a 1 second basis, and this is the LC peak, which is also our LC peak max, or is what it's termed here, but it's the LC peak value, which is also required as part of the assessment process. So one thing that did come to mind is we noticed there was a couple of large spikes, and we were trying to obviously determine what caused them, and it's an interesting study and was almost an accidental finding, but it's certainly something that I was always aware of with unattended noise measurements, is the risk that an employee or employees might contaminate your measurements. And in this particular instance, the employees didn't let us down, and I just thought it'd be useful for somebody who is considering the use of unattended measurements by way of using a dose meter, for example. This is a perfect example of the risks that are associated with the use of unattended measurements, which we don't normally do, and it was good in some respects to be able to view this. So just to explain, you'll notice there's a lot of energy here at some of the higher frequencies. These relate to the forklift reversing. If I play that, you'll hear a reversing beeping alarm on the forklift. So essentially that's your characteristic beeping that you'd get when a forklift is reversing, but the reality is the operator's ear is subject to that. If I play it here, for example, you won't hear any beeping, but you'll hear other activity or industrial noise. Okay, and then there's other noise here, which I can tell from the spectrogram that it isn't high frequency beeping. But it is bangs, loud bangs, that an operator perhaps moving pallets or dropping pallets or something related to the work. But let's take a look at this spike that I noticed here and how that was generated. So I let it play from about here. You'll notice when I play it from here, you'll hear some beeping noise, I would think. You can also hear an operator talking there as well, so some vocal energy there. But just I'll let it play from here and you can have a listen to it.
Oh, yeah, for noise or sound, yeah. Hello!
So in reality, I don't know if obviously you could hear that, but what happens there is employees see a microphone and it's an unattended measurement, and the risk, of course, are it so happens that the employee decided to shout into the microphone and contaminate the measurements. I'm just going to play it one more time so you can hear it.
Yeah, for noise or sound, yeah. Hello!
Okay, so if you look over here on the right, the measured level for that exposure time was 82.2 dBA. Now I can remove that or exclude that measurement by highlighting it. And in fact, if I take um, that person's conversation prior to them shouting into the microphone and I exclude that from it, you notice the level comes down to 81.5. So again, because it's a fairly long exposure time, the contribution is, as I say, it's only, what is it, 1 dB or so. But it is, I suppose, let's delete it again and see. So it's 82.2. But if that was an unattended measurement, and that was, you're working on the assumption that the measurements weren't contaminated, you'd be wrong, because they were. So let's delete it again, and you'll notice that that level goes down to 81.5. So I suppose if unattended measurements had audio recording, it would give you much more useful information, and you'd be able to identify locations like that when loud events. Let's take a look at this one, for example. Here, what created this? So again, they're the forks of the forklift, but it is useful just to know what creates them. Another useful feature then, of course, is the fact that there's a lot of beeping noise or reversing alarms. I could start looking at a scenario here by, well, what would happen if we could reduce that, either by putting an employee into a cabin, or else perhaps using a sounder that didn't generate as much noise. So I could go along and we could take out the contributions from, we'll say, all of the beeping noise, and you'll notice that the level over on the right hand side, I'll just highlight this last element, the level over here, the LAQ has gone down to 79.2. So again, it allows us to look at scenarios and what if scenarios. What if we could suppress that, or else ensure that it wasn't used as often, or perhaps relocate it relative to the operator's ear. So they're useful features to know, but it just goes to show you that you cannot rely on unattended measurements unless you have the facility to go in afterwards and modify them accordingly. So I thought it was a useful event just to demonstrate to you, and just to show you the risks associated with unattended measurements. That's it. Thank you.